Panagdait class, let's take a moment to start our class with a short silent prayer. Let us pray. So, before we proceed to our topic for today, let us have our classroom rules. So first, listen actively when others are speaking. Be quiet and be attentive. Contribute thoughtfully. And fourth, respect different opinions. Did you understand? So, before we dive into our lessons, let's review first our previous topic. So, I will be asking someone to answer the questions. What is a convergent series? Anyone? Okay, very good. Convergent series is an infinite series where partial sums approach a finite limit. That is, as you add more and more terms, the total sum gets closer and closer to a specific value. Second questions and the last questions before we know about what is our topic for today. So what test do we already know for checking convergence? Okay, very good class. So as you may recall, we've already discussed our previous topic. So today we will be moving on to a new one, which is all about alternating series, ratio test, and root test. So, but before that, before we dive into the lesson, let's go over our learning objectives. So first, explain the condition and application of the alternating series test, ratio test, and root test. Second, solve problems involving convergence of infinite series using the ratio and root test. And last, appreciate the importance of convergence in real-life context and its relevance to mathematics. So, before we proceed to our discussions, let us have first our group activity. So, you will be divided into 3 groups. Each group will be assigned a convergent test. So, group 1 will be the alternating series test, group 2 will be the ratio test, and group 3 will be the root test. So, each group will receive a worksheet with 2 problems to solve using their assigned test. So, write your solutions on Manila paper and present your solution to the class and explain why the test is applicable. Did you understand? So go to your group and start answering. So your timer starts now. So time's up. So I have here questions to know if you really understand what did you do or what is of what is your works. So, first questions is, what are the similarities and differences among the three tests? And how do we choose which test to use for a given series? So I will be asking random students to answer these questions. Okay, very good. I think you have already an idea about our topic for today. So, let's dive into our formal discussions. So, our topic for today is all about alternating series, ratio test, and root test. So, what is alternating series? So, alternating series is a series whose terms alternate in sign. That is, the signs of the terms alternate between positive and negative. For example, summation of n equals to 1 approaches to infinity, negative 1 raised to n times a summation of n, or summation of n equals 1 approaches to infinity, negative 1 raised to n plus 1 times a sub n. So here's the example for the alternate sign between positive and negative. So we have positive 1 minus 1 half plus 1/3 minus 1/4 plus the infinity. So to check the alternating series, we have this. We need to apply this test. So let a sub n greater than 0, and so the limit n approaches to infinity, a sub n equals to 0, or the limit a sub n plus 1 less than or equal to a sub n. So it is decreasing, then the summation negative 1 raised to n times a sub n is converges. So let's have our example. So the example number 2, summation of n equal to 1 approaches to infinity, negative 1 raised to n over n squared. So to check if we really apply the alternating series test, so we have a sub n equals 1 over n squared, so it is decreasing. Then we need to test the limit. So the limit n approaches to infinity, so a sub n equals to 0. So from these examples, the series is converges because it applies the alternating series test. Next is the ratio test. This test checks if a series converges by analyzing the ratio of consecutive terms. So given a series summation of a sub n, consider the limit. So we need to use this formula, limit n approaches to infinity, the absolute value of a sub n plus 1 over a sub n equals the limit. So if the limit is less than 1, the series is converges. Then if the limit is greater than 1, the series is diverges. Then if the limit is equal to 1, so the test is inconclusive. So let's have our example. So example, summation of n equals 1 approaches to infinity 8 raised to n over n factorial. So let a sub n equals 8 raised to n over n factorial. So we need to use the formula to test the series if it is converges or diverges. So the formula is limit n approaches to infinity, the absolute value of a sub n plus 1 over a sub n equals the limit n approaches to infinity 8n plus 1 over n plus 1 factorial times n factorial over 8 raised to n. So we need to times it n factorial over 8 raised to n to cancel the factorial and the n plus 1. So equals to the limit n approaches to infinity 8 over n plus 1 equal to 0. So from this example, the series is converges because the limit is less than 1. So example number 2, summation of n equals to 1 approaches to infinity 3 raised to n over 2 raised to n equals summation of n equals to 1 approaches to infinity 3 over 2 raised to n. So to compute limit n approaches to infinity, the absolute value of a sub n plus 1 over a sub n equals to 3 over 2. So from these examples, so the limit is greater than 1 because it is 3 over 2. So if the limit is greater than 1, so the series is diverges. Next is the root test. This test checks convergence using the nth root of terms. So given the summation of a sub n, so to compute, let's use the formula. Limit n approaches to infinity n square root of the absolute value of a sub n equals the limit. So if the limit is less than 1, it is diverges. Then if the limit is greater than 1, it is diverges. The limit is less than 1 convergence. Then the limit greater than 1 is diverges. So if the limit is equal to 1, it is inconclusive. So same like in the ratio test. But the root test is we need to check the convergence using the nth root of terms in truth. So let's have our examples for you to understand. So example, summation of n squared over 2 raised to n. So let a sub n equals to n squared over 2 raised to n. So but using the formula limit n approaches to infinity, n square root of n squared over 2 raised to n equals the limit n approaches to infinity, n squared divide n over 2, so it is 1/2. So the answer is 1/2 and it is less than 1. So the series is converges because the limit is 1/2. So for the example number 2, submission of n equals to 1 approaches to infinity, and 2 raised to n to compute limit n approaches to infinity, and square root of 2 raised to n equal to 2. So from this example, the limit is equal to 2, so it is greater than 1. So the series is diverges because it is greater than 1. Based on the previous slides, if the series is greater than 1, the series is diverges. So that's all. Now I have prepared some questions to test if you really paid attention to my discussions. So I will be asking random students to answer these questions. The questions are: how do these tests help you understand infinite processes in mathematics? And which these tests do you find most helpful and why? Okay, very good. All of you really paid attention to my discussions. So now, you will be answering this assessment. So, for your assessment, answer these following questions in just 10 minutes. So, start answering now because your timer starts now. Time's up. Pass your paper. So kindly sit properly and listen. So for your assignment, you will be interviewing a mathematics teacher from the college department and ask how they apply convergence tests in teaching or research. And with that, write a one-page summary of the insight you gathered. So you will submit this next meeting. Is that clear? So, any questions, clarifications, violent reactions? None? Okay. So, that's all for today. Thank you and goodbye. See you next meeting.